penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi Guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, Assalamualaikum, salam sejahtera, selamat petang dan selamat datang ke kelas tuisyen online percuma yang dibawakan khas oleh anda oleh Akademi Youtuber Malaysia, Kelab Guru Malaysia dan e-didik Malaysia. Bermula percuma, selamanya percuma. Saya Cikgu Hasnitah dari SMK Bagan Jaya akan menemani anda lebih kurang 1 jam pada malam ini untuk satu lagi tajuk kelas tingkatan 4 iaitu 4.3 Specific Latent Heat. Okey, jadi kita lihat dulu siapa ada bersama dengan kita. Kita ada Tarvin di sana, Yo Kawai, kita ada Jimmy. Can you give me some response if you can hear me clearly, Jimmy or anybody else? Boleh dengar cikgu tak? Kalau boleh dengar cikgu, tolong type dekat live chat. Yes, teacher. Boleh cikgu, jelas, clear. Okay, thank you very much for your response. Jadi seperti biasa, sebelum kita mulakan kelas pada malam ini, ayuh kita mulakan dengan bacaan umul kitab dan doa belajar. Bagi yang bukan Muslim, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Okay, thank you Jimmy for your response. Al-Fatihah. Amin, amin ya rabbal alamin. Okay, thank you Chia Yao for your response. Kita juga ada Kai Roheng di sana. Okay, cikgu lihat ada beberapa orang pelajar baru pada malam ini. Anda boleh kongsikan lagi link kelas ini kepada rakan-rakan anda. Mudah-mudahan ramai lagi yang dapat manfaat daripada kelas kita pada malam ini. Okay, sebelum itu anda juga boleh tengok pada pin messages. Cikgu ada pin pada pin message di sana. Anda boleh dapatkan PDF copy untuk kelas kita pada malam ini. Okey, jadi without further ado, mari kita mulakan kelas pada malam ini. Anda boleh nampak slide cikgu ya, boleh? Can you see my slide, student 4.3 specific latent heat. Okay, to Form 4 students, can you respond to me? Where are you? Which topic you are discussing now with your teachers in your school? Sekarang anda belajar di bab berapa kepada student Form 4? Mungkin ada yang sudah advance, mungkin ada juga yang masih ke belakang sedikit. Okay, I hope can get some response from you during conducting this lesson. Okay, thank you Jaya for sharing. Alright, okay, boleh lihat. Okay. Dan kita akan kongsikan juga sijil link express kepada kelas malam ini di hujung siaran nanti. Jadi pastikan anda bersama-sama dengan cikgu sehinggalah ke akhir siaran. Okay, Jimmy hit. Alright, okay. So, are you all ready student? If you are ready, please sit in the most comfortable way. Anda duduk dalam keadaan yang paling selesa. Mungkin juga kena sedia dengan calculator, kertas untuk mengira dan sebagainya. Alright. Okay, so mari kita bermula. Let us begin with today. Before that, this is all the members of Physics panel in Akademi Youtuber. Ini adalah rakan-rakan cikgu di panitia fizik bagi subjek fizik di Akademi Youtuber yang telah banyak membantu cikgu untuk menerbitkan video dan juga mengendalikan slot siaran langsung iaitu kelas kita pada hari Jumaat untuk tingkatan 4, untuk tingkatan 5 dan slot hari Ahad untuk tingkatan 4. Okey, jadi siapa yang belum lagi muat turun aplikasi Akademi Youtuber di Android anda boleh muat turun pada hari ini. Kita ada lebih kurang 26,000 video PDPC di sana daripada pra sekolah hinggalah ke pra universiti, termasuklah untuk subjek fizik. Okey, jadi mudah-mudahan video-video ini membantu anda untuk faham subjek anda pelajari dengan lebih baik. Okey. I also have some students from my school here. Okay, thank you very much for your time. Okay, so student, to begin with specific latent heat, let us begin with this daily situation. Yummy. Siapa peminat cendol, ais kacang di sini? Who loves to eat ais kacang, one of Malaysian favourite dish. Okay, kita ada juga sana ikan steam. Siakap masak steam. Okay, so if you refer to this situation, this is the daily situation which we can closely relate to specific latent heat. Okay, the first one, ais kacang, which is colder than the surrounding temperature, is absorbing heat. Okay, and when they absorb heat, what happened to the ais kacang? Can you tell me what happened to the ais kacang when it absorb heat from the surrounding? Apa jadi pada ais kacang bila dia serap haba daripada persekitaran? And then second, a fish can be cooked by steaming in a steamer pot. What changes happen to the water in the steamer pot when it boil? Apa perubahan yang berlaku pada air dalam periuk apabila dia mendidih? Not ais kacang. ABC, yes, very good. So what happened to the ais kacang when it absorb heat from surrounding? Anyone? Apa jadi pada ais kacang bila dia serap haba daripada persekitaran? Yes, very good, Jimmy. The ais kacang will melt. Melting process occur. So I believe you know melting. What is melting? Changing of phase from solid to liquid. Okay, what about the water in the pot? What happened to the water when it boils? Okay, yes, very good. Bila air mendidih, dia bertukar daripada air kepada wap. When the water boil, it changes its phase from liquid into gas. Yes, very good. And this will cook the fish. Alright, so how do we discuss it? And how we relate this to specific latent heat. Okay, so this is the situation. This is the question that may come up from the two situation I gave you earlier. Okay, tengok soalan dia. Okay, kita ada beaker. We have a beaker here contained with ice cube, and we place a thermometer inside, and the beaker is exposed to heat. Okay, supply from the Bunsen burner. Okay, the question, heat the ice in a beaker slowly, and then what happened to the reading of the thermometer? Okay, initially at the beginning, is there any changes in the reading? Okay, when you heat the beaker containing ice slowly. So definitely in the first few seconds, you find there is no changes in the reading of the temperature, but you will see the ice is started to melt. All right. Okay, so the second question, what is the effect of heat supply to the ice? At this moment, student, when the temperature show no reading but the ice started to melt, we say that the heat absorbed by the ice is used, okay, to weaken the bond between the ice molecule, so that it can change phase from solid, which is ice cube, into liquid when the ice melt. Alright, so I hope you're clear with the first activity. Apabila kita bekalkan haba secara perlahan, kita lihat pada awalnya tiada perubahan pada suhu, tapi kita lihat ais mula mencair. Jadi haba yang dibekalkan tu sebenarnya digunakan untuk melemahkan ikatan antara molekul ais supaya dia dapat berubah daripada fasa pepejal kepada fasa cecair pada suhu yang tetap. Alright, okay. Okay, now the second question. Okay, heat the water in the beaker. Okay, now the ice completely melt into liquid. Okay, the ice has been completely melt into the ice, sudah sepenuhnya mencair menjadi air, berubah kepada air. And then what is the effect of the heat to the water? So at this moment you will see now the temperature of the liquid is started to increase. Alright, okay. I mean when you continue supply heat. Okay, so now you can see the thermometer reading will increases. So, and then we continue to heat even though the water in the beaker is started to boil. Okay, so we heat it until it boil. Okay, so now it has reached the boiling point 100 degrees Celsius. So you continue supplying heat. So again, at that moment, you see the temperature again remain at 100 degree Celsius. All right. Okay, and then in the second question, okay, if not, what is the effect of the heat supply to the boiling point? Okay, so when we keep continue after the water boiling, we keep continue supplying heat, you will find that the temperature remain at 100. Why? Again, at this moment, the heat is used to break up the bond between water molecule so they can change phase into steam. All right. So we have to condition here. First, we supply heat to the ice cube. Then it started to melt, the temperature remain the same, no changes. And then after the water boil, we continue supply heat. The water also remain at 100 degrees Celsius. So at these two condition, the heat is supplied to the ice cube and the water to break up or to weaken the bond between molecules so they can change phase from solid to liquid and from liquid to vapor or to steam. Okay, so I hope you're clear. Yes, very good, Jimmy, to break the bond between molecule. Yeah. Okay. Next student. Okay, this one. So by here we understand what is the name of heat absorbed or given out at constant temperature during change of phase. We go back to the ice kacang just now. When it absorbs heat from the surrounding, okay, if you put a temperature there, the temperature of the ice kacang does not change, but you can see it change phase from solid to liquid. It start melt. So we say that the heat that we supply is called as latent heat. Okay, latent heat. Latent is a Latinian word. It means hidden. Okay, why we say latent? Because we supply heat, but it doesn't cause a temperature change, but only used to change the phase of the substance from solid to liquid, from liquid to solid, or from liquid to gas, or from gas to liquid as well. All right. So this explains to us latent heat. It is a heat absorbed or released during change of phase of a substance at a constant temperature. So you can put a star there on the definition of latent heat. It is the heat absorbed or released during change of phase of a substance at constant temperature. Yes. Okay, so this is our first term in this lesson, latent heat. All right. Okay, next. Let us move to the next slide. Okay, this is example where latent heat is applied. Okay, so when do latent heat absorb? During melting and then during boiling. All right, and when does latent heat is released? During condensation and freezing. All right. Okay, melting is solid changes into liquid, and boiling, liquid changes into gas at constant temperature. While condensation is the other way around. Heat is released at constant temperature, so the gas can condense into liquid. And freezing, latent heat is released at the same temperature where liquid change phase into solid. All right. Okay. So that is the first learning standard to understand or to define what is latent heat. Okay, so now let us move to the second learning standard, specific latent heat of fusion, and specific latent heat of vaporization. Okay, this is the symbol for latent heat L. It is Q divide M. Q is the heat supply or absorbed, and M is the mass of substance. All right. Okay, students. So to understand specific latent heat, it is how much, it refers to how much heat absorbed or released during change of phase of 1 kilogram substance at constant temperature. So there are three keywords there. First, amount of heat or quantity of heat, either absorbed or released. Second, change phase. Okay, change phase, during change phase of 1 kg substance. When you mention about specific, we must mention 1 kilogram substance, then at constant temperature. So this will give us the SI unit for specific latent heat. Symbol L. Q is the amount of heat supply for every 1 kilogram substance M. So the SI unit is joule per kg. Since it doesn't involve temperature change, so you don't see any degree Celsius there in the unit. It is joule per kg. Alright. Then we have two types of specific latent heat. First is specific latent heat of fusion up here. Fusion. Okay, fusion means specific latent heat of fusion refers to the amount of heat either absorbed or released during changing of phase of 1 kilogram substance at constant temperature. Okay. Fusion here involves change from solid to liquid. Okay, or liquid to solid to liquid. Okay, so involve melting and freezing. Melting is the process where solid change into liquid, and freezing, liquid change into solid. Okay, remember fusion involve changing of phase from solid to liquid or liquid to solid. Okay, and then we have specific latent heat of vaporization. From the name vaporization, you know. So it is the heat supply during changing of phase from liquid to gas or gas to liquid, vaporization. Okay, so involve boiling and condensation. Okay, for 1 kilogram substance at constant temperature. So you can highlight the point. You can highlight on the notes I supply to you. You can download them later and print them out for free, and then you can mark the important points there with a highlighter. Okay, we also have Shum Hui Xuan here. Welcome to our class. Can you tell me which school are you from? Okay, everyone, tell me which school are you from. Okay, thank you. Okay, next student. Okay, what do we have next? Okay, let us take a look at this example. Sometimes in the question they ask you, what is meant by specific latent heat of fusion of ice is 336,000 joule per kg. Okay, question mark. Or they ask you the second question, what is meant by specific latent heat of vaporization of water is 2,260,000 joule per kg. So how to explain this? So this figure, this number tells us how much heat is required, okay, to change the phase of 1 kilogram substance at constant temperature. Okay, so here we say, since mentioned latent heat of fusion, so we understand, okay, the process involved is melting or freezing. So we say 336,000 joule of heat required to melt or to change 1 kilogram ice into water at 0 degree Celsius or at constant temperature. All right. And then for here, specific latent heat of vaporization. So we understand we need this amount of heat. 2.26 times 10⁶ joule of heat is required to boil or to change 1 kilogram water into gas or into steam at the boiling point at 100 degrees Celsius, or you can mention at a constant temperature. All right. Okay. So I hope you're clear with this definition for heat capacity in the first learning standard. And then now we discuss the definition for specific latent heat of vaporization, and specific latent heat of fusion. Ya, cikgu ada ajar sains, ada je yang cikgu ajar sains form 5 tahun ini. Cuma untuk kelas online, cikgu fokus untuk kelas fizik sahaja. Alright? Okay. Okay, next student. Okay, you are given this question. Okay, let us take a look together. You can respond to me as well. Anda boleh cuba jawab persoalan ini bersama dengan cikgu. Okay, they ask you why the value for specific latent heat of vaporization of water is greater than the value of the specific latent heat of fusion of ice. Just now you compare this. Okay, the specific latent heat of fusion is 3.34 times 10⁵ only, but for latent heat of vaporization is 2.26 times 10⁶. So why this figure is bigger? Okay, why we require more heat To make it simple, why we require more heat to convert water into steam than to convert ice into water. Alright. Okay, I think it's more clear for you. Why? Okay, kenapa perlukan haba yang lebih banyak untuk menukarkan air kepada steam daripada menukarkan ais kepada air. Okay, itu persoalannya. Okay, that is the question. Why do you think? So this is the reason. This is because we require more energy. Okay, we require more energy to weaken. Okay, it's mentioned here. Okay, before that you must understand what is meant by specific latent heat of fusion. It is the energy used to weaken the bond between solid molecules so they can move freely as water molecule, whereas specific latent heat of vaporization, okay, is the energy used to weaken the bond between liquid molecules so they can move freely as gas particle. Alright, so why we require more heat to do that? Okay, Jimmy say here to increase kinetic energy. Okay, so actually the answer has been shown here. Okay, number one, in order to convert from water into steam, okay, a lot of energy is used first to break the bond between the water molecule and separate them far apart from one and another. And then second is to overcome. Okay, this is the extra work it has to do. For solid to water, you only need the energy to break the molecule of solid so it can move freely as water molecule. But from liquid to gas, the energy is used to do two things. First is to break the molecule bond between the water molecule so it can convert into gas, and second to overcome the atmospheric pressure to enable the molecule of gas to escape to the surrounding as gas. Okay, so this is the reason why we require more heat, okay, to change liquid into gas rather than to change solid into liquid. So are you clear with the explanation here, student? If you do, you can type number 1 in the live chat. You type 1 in the live chat. Why we need more heat, okay, to convert liquid into gas instead of converting solid into liquid. Okay, this is for to break the molecule and to overcome atmospheric pressure so it can move freely as a gas particle to the surrounding. Okay, very good, Jimmy. I hope anybody else can give me number 1 so you understand why. Okay, specific latent heat of fusion of ice is greater than specific latent heat of vaporization. All right, student, we move to the next slide. Okay, so this is one of the also important part you must understand, the heating curve. The heating curve and the cooling curve. We also have Joris here. Thank you, Joris, for joining me. Kavya. Okay, we also have Kavya Sagunan. Hello, Kavya. Okay, look at this heating curve. We have a few phases for you to check on. So I mark here 5 stages. Okay, 5 stages. So you see the heating curve. Okay, so the heating curve, it must goes up. Okay, the heating curve, the curve goes up. So initially, this is the state of phase of our substance. Ice mean in solid. Okay, in solid form. You supply heat to the ice. Initially, the ice has a temperature of -10 degrees Celsius. So you supply heat to the ice, then okay, the temperature reduced to 0 degrees Celsius but still in the ice form. Okay, and then you keep supplying heat. Now the ice started to melt. Okay, see, when melting happened, the curve has a straight line, meaning the temperature doesn't change, but the phase is changes from solid to liquid here. Okay, so this is the explanation for each part here. Okay, heat is absorbed by the ice molecule, the kinetic energy increases, so the temperature increases from -10 to 0. And then at the second phase, we keep supplying heat. Now the heat is absorbed, but to break the molecule between ice molecule, so it can melt into water. That's why the temperature here is constant. And then continue supply the heat, student. So now in the third phase. Okay, now the ice started to boil. Okay, it started to boil here. So at this phase, heat is absorbed again to increase the kinetic energy of the molecule. That's why the temperature rise. So here you understand whenever the kinetic energy increases, so the temperature must be increases. Okay, now it reached the boiling point, 100 degrees Celsius. Okay, so again, this is a changing of phase from liquid started to vaporize into gas. All right, and then finally at the fifth stage, the water completely change into gas. So you can see the first, the third, and the fifth step, same thing happen. Heat absorbed, okay, to increase the kinetic energy, so the temperature increases. And then in the second and fourth stages, heat absorbed at constant temperature because heat is used to break the molecular bond, so the substance can change phase. Okay, here from solid to liquid, and here from liquid to gas. All right, okay, good. Okay, if you clear with the heating curve, give me number 2, type 2 in the live chat. All right, okay. Next, cooling curve. So the same thing happen. Cooling curve mean when the heat is released. Heating curve, the substance absorb heat. Okay, so cooling curve, the substance release heat. So you can see the temperature decreases from the beginning to the end. Also, we have 5 stages here. 5 different phases. Then phase number 1, phase number 3, and phase number 5, same thing happen. Heat released by the substance, the kinetic energy of the molecule decreases, so the temperature decreases. And then in stage 2 and stage 4, this is the phase where changing of phase occur. Okay, so heat is heat is released, so that the kinetic energy is constant, the temperature is constant. Heat is released, so the molecule of the substance is rearranged back. So to change phase from gas to water here, and to change from water into ice here at the 4th stages. All right. Okay. Good. Okay. So that is the first and second learning standard. So what if learning standard? So don't go away. I will be back soon. Okay. Thank you for being with me. Okay, kita rehat dulu sebentar. Kembali lagi selepas ini. Alright. Okay, thank you very much everyone for still being with me. I'm Cikgu Hasnitah from SMK Bagan Jaya, and now you are watching the online tuition class for Physics Form 4 with a topic 4.3 specific latent heat. Okay, so we have readily discussed the first 2 learning standard. Now let us take a look at the 3rd learning standard, where this is actually involves some experiment. So I believe later in school you will conduct the experiment together with your teachers in the laboratory. So in this experiment, it shows you how we study the specific latent heat of fusion of ice and specific latent heat of vaporization of water. So I will show you this experiment in a glance just to give you an idea how we conducted in order to determine the specific latent heat involved situation or condition. All right. Okay. Okay, so actually you can find this in your textbook. You can check on which page. This activity and experiment 4.3 is to determine specific latent heat of fusion of ice. So this is the arrangement of apparatus and material required. So you can check for further detail in your textbook. Okay, the apparatus is readily mentioned here. Okay, then this is the procedure from number 1 to number 5, how we should conduct the experiment accordingly. Alright, so later you can read back from the module I shared to you and also from your textbook. Alright, okay. So let's say this is the result we obtained from this experiment. Alright. So this is, let's say, the mass of beaker 1, 50 gram, the mass of beaker 2, 52 gram, okay, mass of beaker 1 plus water, let's say this is the reading, mass of beaker 2 plus water, 78 gram. Okay, so here, how to find energy supply by the immersion heater. So this is the formula we require. Q is amount of heat supply by electrical appliances. So it is the power of the electrical appliances, which is 36 watt. You can read just now in the apparatus. Multiply the time of usage. So the time of usage is 10 minutes. So 10 minutes convert into second, multiply 60. So 21,600 joule of heat is supplied by the heater. Alright. Okay, and then this is how to calculate the mass of ice melt in beaker 1. So we minus, okay, mass of beaker together with water and minus with the mass of beaker itself. So you get the mass of ice, 58 gram. And to find the mass of ice melt in beaker 2, also you minus mass of beaker together with water, minus with the mass of beaker 2, 52 grams. So it gives us 26 gram of ice has been melted in beaker 2. Alright, okay. Yeah, hello Ziyuan, sorry. Welcome to our class. Alright. Okay, then this one, to find the mass of ice melt due to heat from the immersion heater, students. So this is the formula, 58. Okay, mass of my ice melted in beaker 1 minus with the mass of ice melted in beaker 2. Okay, from the procedure and apparatus, you will understand which one, what is beaker 1 and what is beaker 2. Okay, so we find the mass. 32 gram. So in kg is 0.032. So from here, we can calculate the specific latent heat of fusion of ice by this formula. Remember just now, L equal to Q divide M. So Q here, the amount of heat supplied by the heater equal to the amount of heat absorbed by the ice. So PT, 21,600 divide with the ice melt due to immersion heater, 0.032 kg. So we get this figure, 675,000 joule per kg. Alright, okay. So later you can check back and try to digest how to understand this result. Alright, okay. Next. Okay. Okay, kita juga ada HR Zarina channel here. Thank you very much for joining and supporting us tonight. Okay, may this lesson benefits to those who follows, especially to Form 4 and Form 5 students who learn physics. Alright, okay, so this is the question come up from this experiment. In this experiment, explain why the stopwatch is not started immediately after the heater of set 1 is switch on. Kenapa kita tak start stopwatch dengan segera? Kenapa kena tunggu sekejap? So, yes, this is to give time for the ice to melt constantly. Okay, because remember initially when we started supply heat, the temperature does not rise yet. Okay, because at that moment, the ice absorb heat just to convert, okay, the phase from ice into a liquid. So we give some time for the ice to melt constantly. Okay, next, set 2 is known as control set. This is normal. Whenever we conduct experiment involving heat, normally we prepare for 2 sets, the experiment set and the control set. So we can make comparison. So set 2 is known as control set. Explain why the necessity of having control set in this experiment. Okay, so this one to differentiate the heat absorbed, okay, from the heater and then the heat absorbed from the surrounding. Okay, so in set 2, it doesn't supply with the heater. Okay, the ice melt naturally by absorbing heat to the surrounding. So later we can make a comparison. Okay, then we can calculate, okay, the specific latent heat of fusion, just referring to the heat absorbed by the heater. Okay. Next, kita tengok contoh soalan yang seterusnya. Okay. Compare the value of specific latent heat of fusion of ice you obtain from this activity to the value given in the textbook. Okay, normally student when we do activity, we will find slightly different. The value we determine from experiment is slightly higher from the actual value. Okay, why? Okay, so this is the standard value given in the book. Specific latent heat of fusion of ice is 3.34 times 10⁵ joule per kg. But from the calculation just now, you'll find the value in the experiment is higher than the standard value because in the experiment, heat is also absorbed from the surrounding. So we cannot do experiment in a closed container, so there will be some heat also absorbed from the surrounding. So that's why the value is higher than the actual value. Okay. Okay, and the second experiment to determine specific latent heat of vaporization of water. So the setup is more simple. We have a big water placed in a beaker covered with tissue paper. Okay, so this is to ensure there is no heat absorbed or lost to the surrounding. The immersion heater is placed to supply heat to the water, so it can vaporize into gas or steam. So you can read the apparatus, material and procedure from number 1 until number 5. So this experiment is conducted in 5 minutes. Okay, in 5 minutes. So initially we measure the mass of the water, and then after 5 minutes we measure again the mass of water left in the beaker, so we know how much water has been converted into gas or steam. All right. Okay. And let's say this is the result we obtained from this experiment. Okay, this is the result. Initial mass of water before heating, 4 to 4 gram. Okay. Final mass of water after heating. Okay, 362 gram. Why? Decreases? Yes, very good, because some water has been converted into gas. And time required 5 minutes in second, 300 second. This is the power of the immersion heater, 1000 watt. Okay, so from the power, we can calculate how much heat required by the heater, PT. Power multiply 300. So it will give you 30,000 joule. Alright, so mass of water which boils, so we minus. Okay, the final initial mass and final mass. So we know 62 gram of water has been boiled, has been converted into, yes, into gas. So then we can find the specific latent heat of vaporization. Q divide M. So Q, heat absorbed by the water, equal to the heat supply by the heater. Then the value 4,838,709.677 joule per kg. Okay, so I hope you can understand how we figure out the specific latent heat of fusion of ice and vaporization of water through these two examples of experiment. And this is the discussion might come up. Do you expect the value of specific latent heat of vaporization obtained in this activity smaller or larger? Okay, so as you can see, it is larger or higher than the standard value because same reason as before. Water is also absorb heat from surrounding, which contribute more steam to be released. Okay, the actual value is just 2 million, but just now we get 6 million or 8 million, is it? All right. Okay. Okay, so that's all with the experiment. Okay, now where in our daily life we can see this or we apply specific latent heat, all right, either fusion or vaporization. Okay, number 1, when you go to the market to buy fish, okay, prawn and so on. Bila anda nak pergi beli makanan laut dekat kedai, you will say, where did they keep the fish at? Di mana mereka simpan ikan tu? Okay, so normally they keep in an ice box. Okay, why? This is to maintain the freshness of fish and meat by placing them in contact with ice. So what happens to when the fish or the meat came in contact with ice? How do the ice do that? Let's say this question 4 marks. Explain why, how the ice can maintain the freshness of the fish and meat. 4 marks. So how to get 4 marks? Okay, number 1, we can write ice has a large specific latent heat of fusion. Okay, ice has large specific latent heat of fusion. Alright, okay. It absorbs large amount of heat from the fish as it melts. Okay, the second point. Now the temperature of the fish decreases, thus the fish can be kept at low temperature for a longer time. Okay, so this is how we explain. Okay, second situation. Okay, when you cook a fish in a steam way, how steam is used to cook. Bagaimana steam digunakan untuk memasak? Okay, so how? Okay, so number 1, you can say water has large specific latent heat of vaporization. Okay, mention water has large specific latent heat. Specific latent heat is released directly to the fish. So this heat enable to cook the fish faster. Okay, the explanation. Okay, next, the third situation. Okay, we always experience this. After sweating, we feel a cold sensation in our skin. Okay, you akan rasa sejuk dekat kepala tu, sejuk. Alright, okay. We sweat. Kenapa rasa sejuk selepas kita berpeluh? Okay, why? Alright, so number 1, you can say the sweats on the body evaporates. Okay, so when the sweat on the body evaporates, okay, what happened? It absorbs it absorbs specific latent heat of vaporization from the body. Okay, the body, so by this it will removal of the heat, so the rate of evaporation will increase when there is air circulation. When you sit under fan, it will help you to remove the heat at higher rate, so you'll feel cool down quickly. Alright, okay, so I hope you are clear with that. Okay, okay students, okay, next situation. Let us take a look at the next situation. Okay, refrigerator. Saya percaya semua rumah ada peti ais. Okay, kebanyakan rumah ada peti ais. Do you know how the cooling mechanism occur in the refrigerator? Tahukah anda bagaimana sistem penyejukan dalam peti ais itu berlaku? Bagaimana peti ais itu dapat sejukkan makanan dalam tu? So mengekalkan kesegaran. How the cooling mechanism in the refrigerator occurs? Okay, so if you see here, it divided into 5 stages. Okay, the cooling mechanism in the refrigerator. Okay, first you can tell the cooling agent use. It use freon. Okay, the cooling gas. Okay, and the cooling agent compress to increase the pressure and temperature. Ini peti ais yang model lama lah. Okay, peti ais model lama. Okay, so the cooling agent compress to increase its pressure and temperature. So when this happen, the refrigerator use the cooling effect from the evaporations of the freon liquid. Now, so during condensation of cooling agent, which is the freon in the cooling system, latent heat is absorbed from inside the refrigerator. So whatever heat from the food is absorbed, okay, then the heat is released to the surrounding from here, okay, from the expansion valve, the condenser, and so here at each number you can see which part is functioning from number 1 up to number 5. Okay, number 1 is here, down here, compression occur. Okay, then refrigerator use the cooling effect, okay, along this path. Okay, number 2. And in number 3, during condensation, cooling agent, cooling system, it absorbs heat from the refrigerator. Then finally, the heat is released, okay, to the surrounding back here. Okay, but in a modern refrigerator, you can say the structure is slightly different. You don't see this structure at the back anymore. You just see flat surfaces. Alright, okay. And the last part of this discussion, okay, now the most important part, let us try to solve some problem involving latent heat. So you can prepare with your calculator, your pen and paper as well. Okay, let us try this first. Okay, so from what we have discussed just now, this is the conclusion we can make. Okay, ini kesimpulan dapat kita buat when heat absorb. Okay, either absorb or release during when heat absorb or release changes the temperature of a substance. The heat is calculating using Q equal MC delta theta. Okay, this is what we learned in 4.2, specific heat capacity. Okay, specific heat capacity involving temperature change. But what we learned tonight, when the heat absorbed or released changes the phase of a substance at constant temperature, so we calculate the heat using Q equal ML. You see, there is no delta theta there. Alright. Third, if heat is applied by electric heater, okay, to change the phase of a substance, so the equation Q equal to ML can be written as Q equal PT. Okay, Q equal PT equal to ML. Alright, where P is the power of the electrical devices and time T is the time of operation in second. Alright. Okay. Okay, let us try this. Okay, first example. Just an easy one, student. Okay, let us work together. You are given 2 kg of ice, melts when we supply 452,000 joule of heat energy. So what is the specific latent heat of the ice? Okay, so you are given M, 2 kg, Q, 452,000, and what is L? So this is a very straightforward answer. Okay, who figure out the answer? Can you share to us in this live chat? Okay, I really appreciate if you can share your answer. Okay, boleh cuba kira berapa haba pendam tentu ais dalam kes ini. Kita ada 2 kilogram ais yang mencair, melting apabila dibekalkan haba sebanyak 452,000 joule. Alright, okay. So what is the formula? Yes, the formula is Q equal ML. So we are looking for this L. So what is it, students? Okay, come on. Okay, yes, very good. So this is Q, 452,000. So the mass is 2. So we are looking for L. So how to find L? 452,000 divide 2 kg, students. So this is the answer, 2.26 times 10 power. So you can leave your final answer either in the first state, macam ini pun boleh, okay, or the second way. You put it in a scientific notation, no problem. Okay, next. Okay, next question. Okay, number 2. Now we have immersion heater supply heat at this rate, 50 joule per second. This is quite different. It say the heater supply heat at this rate, 50 joule per second. Mean for every 1 second it supply heat of 50 joule to an insulated vessel containing a liquid. Okay, as shown in this diagram, the liquid is brought to its boiling point and kept boiling for 2 minutes. Okay. The question is, during which time the mass of the liquid lost 40 kg? What is the value of specific latent heat of vaporization of liquid. Okay, the question asks you to find the specific latent heat of vaporization of liquid. Okay, so actually from here, joule per second, it gives you the power. What is equal to joule per second? So this is the power of the heater. 50 joule per second equal to 50 watt. So time of operation 2 minutes, which is equal to 120 seconds. And how much liquid loss or convert into a vapor? 40 gram. Okay, 40 gram in kg, 0.04. So we can find the specific latent heat of vaporization. Simple. Okay, so kira lah. So you know what is PT? Yes, very good. PT is the heat supplied by the immersion heater. Okay, heat supplied by the immersion heater, and this is the heat absorbed by the water to vaporize, ml. So power 50, time of operating 120 second. So the mass loss 0.04 convert into steam or gas. So we can find LV as well. So answer 1.5 times 10.5 joule per kg. Alright? Okay, very good. Okay, next. Okay, question number 3, student. So I hope you're still there with me. Okay. And for those who are just joining us, I have shared these exercises in the video description below. So you just click on the link. You can download the PDF copy, and also you can print them out all for free. Percuma saja cikgu bagi. Okay. Third question. Immersion heater. Again, we have immersion heater with this rate 500 watts. So this is the power fitted into a large block of ice at 0 degrees Celsius. Okay, the specific latent heat of fusion is now given. They give us the specific latent heat of fusion. So now we have to find the time, okay, to melt 1.5 kilogram of how long is it required to melt 1.5 kilogram of ice by using 500 watt immersion heater. Okay, so how to find time? Q equal ml. Q here represent by PT, power multiply time of operating, 500. Okay, now we are looking for the time. Okay, so this is the mass 1.5 and given specific latent heat of fusion. So you just solve them, okay, mathematically. So how to find the time? It require 1002 seconds. Yes, very good. Okay, Jimmy, yes, very good. Okay, next student. Okay, number 4. Okay, now we have this case. Okay, you can see the arrow there. Okay, we have 0.5 kilogram of water initially at 30 degrees Celsius, heated, supply with heat, until all of it converted into steam. Okay, initially the water 30 degrees Celsius, finally all converted into steam. Okay, so what is the amount of heat energy supply to it? So you're given this info, specific latent heat, specific heat capacity of water, and also specific latent heat of vaporization of water. So if you refer to the cooling, to the heating curve just now, okay, when we convert, okay, water initially at 30 degrees Celsius into fully converted into steam. So it require 2 stages. So the first stages, the water at 30 degrees Celsius when you supply heat, so it will boil. So this is the first stage. Okay, the water boil from 30 degrees Celsius to 100 degrees Celsius. Okay, and then this is the changing of phase. Okay, the changing of phase here occur. Water at 100 convert into steam at 100 degrees Celsius. So at these 2 stages, here we supply specific heat capacity. The heat involved is specific heat capacity. Okay, and then at the second stage, this is involved specific latent heat of vaporization. Remember here got temperature change, so we use MC delta theta. Okay, here changing of phase at equal temperature, so it involves ml, okay, mlv. Alright, so how to find 30 degrees Celsius water into 100 degrees Celsius water. So MC delta theta 0.5 multiply 4,200 multiply temperature change 70 degree. Yes, Jimmy, very good. Okay, yeah. Okay, we also have Tiva. Hi Tiva, thank you for joining us. How do you do? Okay, so 147,000 joule. Okay, what about here? The next stage, 100 degree Celsius water, change phase to 100 degree Celsius steam. So involve mLV. Okay, the mass 0.5. This is the specific latent heat of vaporization. So this amount. So then to find the total, you have to sum both. Okay, Q1 plus Q2. So the total amount of heat required is Q1 plus Q2 equal to 1,277,100,000 joule. Never mind, Tiva. It's better late than never, right? They always say that. Okay, later you can you can rewatch, okay, from the beginning after we ended this lesson. You can watch whenever you are free, okay, after this. Okay, next student. Okay, question number 5. Okay, question number 5. We have 3.2 kilogram of water now, initially at 28. So you can highlight all the important points given in the question, student. Heated until half of it changes to steam at 100 degree Celsius. All right. The question is, how much heat energy need to be supplied to the water during this process? All right. So how to know how much heat is involved. So you can break the process into two parts as well, two stages. Okay, first we have 3.2 kilogram water initially at 28 degree Celsius. So when we heat, it will boil at 100 degrees Celsius. Okay, 3.2 kilogram water at 100 degree Celsius. And then it say until half changes to steam. So you keep supplying heat until from 3.2 become 1.6, okay, at 100 degree Celsius. So again, here involve temperature change. So the heat involved is Q equal MC delta theta. Okay, so 967 680 joule required to change 3.2 kilogram water at 28 degree to 100 degrees Celsius, to boil it at 100 degrees Celsius. And then here, no temperature change, only changing of phase from water into a half 1.6 kilogram steam. So the heat involved mLV, okay, 1.6. So 1.6 have lost, been converted into steam. So this is the specific latent heat of vaporization given. So it requires this much. Again, to find the total, you need to sum Q1 and Q2. So they will give you this value. Okay, they will give you this value. Yes. Okay. Yes, Jimmy. Okay. The half go to the next part, Jimmy. Half ml. Okay, MC theta plus half ml. Alright. Okay. Okay, clear? Okay, very good. Okay, now let us do some objective question. We rarely do objective question, but tonight let us go for some objective question. So you can share your answer, either it is A, B, C or D in the live chat, student. Okay, first, latent heat is hidden. Remember, latent is a Latinian word. It means hidden. Okay, hidden. So latent heat is hidden. Why hidden? Is it cannot be measured? Is it because does not actually exist? Or is it because it is a form of internal kinetic energy, or because it is used to overcome the attractive force between the molecule? Okay, why we say it is hidden, student? A, B, C, or D? Latent heat. Answer is, okay. So what is the answer? Is it A, B, C, or D? Yes. Yeah, for those who missed the first part, you can watch the replay later on, no problem. Okay, it will be found in a YouTube in the same link. Okay, why hidden? Yes, very good, because it is used to overcome the attractive force between the molecules, so it can change phase from solid to liquid, liquid to gas, or the other way around. Okay, specific latent heat, measure in what unit, students? Specific latent heat. Is it A, joule per degree Celsius, or B, joule per kilogram per degree Celsius, or is it C, joule per kg? Remember, latent heat does not involve temperature change. So you're supposed not to see degree Celsius there. Yeah, so clearly the answer is C. Yes, very good. Okay, then number 3. Okay, they give you a heating curve. Okay, heating curve for substance Y. So what is happening at QR? Okay, I zoom this for you a bit. Okay, what happened at QR, student? Okay, what happened at QR? This is QR. Okay, what happened here? Is it A, substance Y is being heated up, or B, substance Y is boiling at its boiling point, or C, substance Y is melting at its melting point, or D, substance Y undergoes chemical changes? Okay, which one? Okay. Is it A? Is it B? Is it C? Yes, at this region, what happened? This is melting process. Okay, substance Y is melting at its melting point. Yes, very good. Number 4, specific latent heat of fusion of ice. Refer to the heat required for what, student? Specific latent heat of fusion is the heat required for what? Is it A, change 1 kilogram of ice into water at 0 degrees Celsius, or to change 1 kilogram water into steam at 100 degrees Celsius, or to change temperature of 1 kilogram ice by 1 degree Celsius? Or is it D, change the temperature of 1 kilogram water by 1 degree Celsius? Latent heat of fusion. So latent heat does not involve temperature change. So fusion, remember, fusion is changing phase from solid to liquid and liquid to solid. So which one? Yeah, answer A. Very good. Okay, good. Okay, next. For B, it is specific latent heat of vaporization. Okay. Next. Okay, number 5, student. There is no rise in temperature when heat supplied to a melting ice. Which of the following explain this observation? Why there is no rise in temperature when we supply heat to a melting ice? When we supply heat to melt the ice. Why? Is it A, heat is used to exert pressure on molecule? Is it? Or the heat is used to increase the vibration of molecule? Increase in vibration mean to what? Okay, increase the, is it used to increase the kinetic energy of the molecule, or heat is used to overcome the attractive force between molecule? Okay, which one? Okay, this one, yes, heat is used to overcome the attractive force between molecules. So it can change phase from ice into liquid. Yes, okay. Number 6, drinks can be cooled by adding several cubes of ice. So what happened when the ice melt? What happened when the ice melt? Is it A, large amount of heat absorbed and lower the temperature of the drink? Or B, large amount of heat is released and lower the temperature of the drink? Is it the kinetic energy of the water molecule increases? Okay, which one for number 6? Okay. The statement drinks can be cooled by adding several cubes of ice. So when the ice melting, what happened? Yes, large amount of heat is absorbed and lower the temperature of the drink. Okay, then number 7, we have cooling curve. Okay, cooling curve of substance. We have 4 phases there: VW, WX, XY, and YZ. 4 phase. Okay, at which stage specific latent heat is released? Which stage, student? Is it VW and XY? So this is a combination. You have to look carefully. Or WX and YZ? Or is it VW and YZ? Or is it WX and XY? Which one? Yeah, clearly it is WX and YZ. Specific latent heat release at constant temperature, which is WX and YZ. Okay, very good. Okay, now our last part, we discuss some SPM past year question, okay, involving specific latent heat, okay. Okay, so number 1 here. Solid substance with this mass, 0.1 kg, heated using 200 watt heater. This graph, okay, a graph show in variation of temperature with time is shown in figure below. So this is the heating curve, okay. WX, and then we have XY, and then we have YZ. 4 stages there. 3 stages. WX, XY, and YZ. Okay, based on the graph, you have to state the matter. You have to write the state of matter of the substance at each point, WX. Okay, what is the state of matter here? Is it solid, is it liquid, or is it gas, or is it a combination? Which one? At WX, student. Okay, what do you think? WX, initially the substance exists at solid. Yes, solid. XY, solid and liquid. Okay, and then YZ is liquid. Okay, YZ is liquid. Okay, second, using kinetic theory of matter, explain why at section XY. Okay, why here? Section XY from 2 to 9 minutes. The temperature is remain constant at 0 degrees Celsius. Okay, why? So if you follow the first part of this lesson, you understand at this point, the energy is used to weaken the bond between solid molecule. So the kinetic energy does not change. So that's why the temperature remain constant. Okay, so two point you can write there. First, energy is used to weaken or to break the bond between solid molecule. So the kinetic energy does not change. Alright, and then here YZ, why the temperature increases? Okay, here the kinetic energy increases. The heat is absorbed to increase the kinetic energy. So when kinetic energy increases, temperature increases. Okay, kinetic energy increases, temperature increases. Alright. Okay, next. Using the graph, determine the melting point of the substance. Okay, can you tell me the melting point of the substance? Easy, just check from the graph. So this is the melting point. Okay, 0 degree. Melting occur in this region, XY region. So melting point 0 degrees Celsius. Okay, then find the specific latent heat of fusion of the substance. So latent heat of fusion involve phase change from solid into liquid, so it happened here. So yes, PT equal ml. PT 200 is the power time of operating. See here how long? From 2 to 9 minutes. So involve 7 minutes. So 7 minutes in second multiply 60. And the mass 0.1 kg. So by this we determine the specific latent heat of fusion 840,000 joule per kg. Alright, okay, very good, simple. Okay, next. Okay. Next question. This is taken SPM 2007, very long time ago. Okay, I think you still didn't born at that year. Am I right? Okay, 2007. Okay, diagram show change of phase when 1 kilogram of ice converted into steam. So you can highlight. We have 1 kilogram of ice converted into steam, and this is the process it took. Initially, we have 1 kilogram ice at 0 degrees Celsius. First, okay, the ice melt into water at same temperature. Okay, Q1. This is the heat involved here. Second stage, from S to T. Now, the water boil. Okay, from 0 to 100 degrees Celsius. Okay, this is the heat required. Q2. And then, the third stage, okay, this is where the vaporization occur. Okay, 1 kilogram water at 100 degrees Celsius convert into steam at the same temperature. So this is the amount of heat required, Q3. So we have 3 stages here, RS, ST, and TU. Okay. Okay, then you have to name the heat energy Q1, which is absorbed from R to S. So what is the name of Q1, student? Q1. Q1. Okay. See here, does not involve temperature change, right? So the name is latent heat. Okay, latent heat. And you can add on latent heat of fusion. Why fusion? Because ice convert into water. Yes, latent heat of fusion, Jimmy. Okay, fusion. Correct. Okay, state one reason why temperature at R and S is the same even though heat is supplied. See, same question. Why temperature remain the same even though we keep supplying heat? So what is done by the heat here? Yeah, so the heat is used to weaken or to break the bond between molecule, and kinetic energy not increases. Okay, next. Find the heat energy Q2. See Q2. Q2 involve temperature change 0 to 100. So it must involve Q equal MC delta theta. Okay, MC delta theta. So here they give you specific heat capacity. So MC delta theta, mass 1 kg. C, specific heat capacity 4,200. And the temperature change here. Where to see temperature change? 0 to 100. So the temperature change 100. So 4,200, 420,000 joule. 420,000 joule. Yes, very good. So final question, you have to sketch. Sketch the graph of temperature against time. So sketch, how to sketch? From R to U. So here from R to U, how do we sketch? So we sketch this way. Initially, okay, ice at 0 degree melt into water at 0 degree. So this is RS. Here is RS. Okay, the straight line RS. And then here ST. This one. Water 0 degree Celsius to water 100. So this part is ST. And here is TU. Ini tak ada lah. This part tak ada This one we don't have. Ini tak ada. Okay, this one. This is R. Can add. This is S. This is T. And here is U. Okay, so this is our, how we sketch our graph of temperature against time from R to UR as involve changing phase at constant temperature ST. This one temperature raise from 0 to 100, and then TU conversion of phase, changing of phase at constant temperature at 100. Yes, you have to label the stages on graph. Correct, Jimmy. So you have to add on R, S, T, and U. 0 degree, 100 degree Celsius. Okay, I left one more here. The unit here for temperature. You put that degree Celsius. Okay, this is temperature at degree Celsius. Okay, you add on the label of the axis and then the temperature 0, 100, and then the stages R, S, T, and U. Alright? Okay, very good, students. Okay, next. Okay, I think this is our last question for tonight, SPM 2008. Okay, you're given this diagram to show 500 watt. This is the power of the heater used to heat a beaker of water on a compression balance. So we put on a compression balance so we can see the changing of mass, okay, during the heating process. So the first question state the energy change involved when using heater to heat the water. So they ask you for energy change. So what energy change to what energy? Okay. So yes, electrical energy convert into heat energy. Okay. Electrical energy to heat energy. Electrical energy is the energy supplied by the heater, and heat energy is energy absorbed by the water. So the conversion of energy is electrical energy to heat energy. Okay. Then the mass of the water 0.5 kg and specific heat capacity is 4,200. Okay, this one we erase 10 there. Okay, 4,200 joule per kg per degree Celsius. Initial temperature is 30 degrees. So you highlight this is the mass, this is the specific heat capacity, and this is the initial temperature. So calculate the energy absorbed, mean we are looking for Q. How much heat is absorbed by the water to reach its boiling point. So what is the boiling point of water, student? 100 degrees Celsius. So this gives us the change in temperature from 30 to 100. So the change in temperature or delta theta is, yes, 70 degree Celsius. Okay. So Q equal MC theta, MC delta theta. Mass 0.5, C 4,200, temperature change 70 degree. So they give you 14700. Can you check either my answer is correct or not? Is it 147,000 joule? If it is correct, you type number 3 there. Yes. Okay, then last question. When the water is boiling, students, the reading of the compression balance decrease. Say decrease by 0.0125 kg in 60 seconds. Okay, so calculate the specific latent heat of vaporization of the water. Okay, so he say the mass decreases by 0.0. So where is this go? This one has been converted into steam. It doesn't lose, it has been converted into steam. So to find the latent heat of vaporization, we use again PT equal to ml or Q equal to ml. So Q here represented by PT. Electrical energy supplied by the heater equal to the heat energy absorbed by the water. Okay, so you just do the substitution. So our specific latent heat of vaporization is 2.4 times 10 power of 6 joule per kilogram. Okay. Okay, so I hope you are clear with all these questions I have discussed tonight. So actually 4.3 specific latent heat is not that specific latent, only specific latent link for the ECET. So you can click on this link to get your certification for tonight lesson. Just type your name and your IC number correctly and the e-cert will be sent to you just in a blink. You akan terima sijil dengan segera. Dia akan sampai ke, boleh guna mana-mana email, boleh guna personal email or MOE email, whatever email you have. Alright, just fill up your name and IC number correctly. So I would like to thank you very much for your time and effort. Terima kasih bersama-sama dengan saya Cikgu Hasnitah pada malam ini. Mudah-mudahan apa yang saya bincangkan sedikit sebanyak membantu anda untuk faham tajuk ini dengan lebih baik. For those who missed the first part, you can always watch the replay dan jangan lupa kongsikan link kelas kita dengan kawan-kawan yang lain. You can share in your social media as well. Terima kasih kepada yang subscribe dan support channel Cikgu Hasnitah. Semoga kita berjumpa lagi di masa-masa yang akan datang. Terima kasih kerana sentiasa bersama kami di Akademi Youtuber. Sesungguhnya yang baik daripada Allah, yang buruk itu semua daripada kelemahan dan kedangkalan ilmu cikgu. Jadi insya-Allah kita jumpa lagi dalam kelas-kelas yang akan datang. Assalamualaikum, bye-bye and have a good rest everyone. Jumpa lagi. Bye. Assalamualaikum. Selamat malam semua.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.academyyoutuber.com. Berusaha AYU, capai kecemerlangan, berpadu AYU, cipta kegemilangan, bersatu AYU, bina wadah terbilang, terus berjaya bersama AYU.
Berusaha AYU, capai kecemerlangan, berpadu AYU, cipta kegemilangan, bersatu AYU, bina wadah terbilang, terus berjaya bersama AYU.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.